channel, and today I'm going to be talking about inverse functions in calculus. And today we're going to be differentiating them. So first of all, I want to establish a relationship. So let's define two things. The first thing I want to define is f of x and g of x. F of x is going to be our main function, and g of x is going to be the inverse of f of x. Now, notice that g of f of x is going to be equal to x, and f of g of x is going to be equal to x. This is going to be part one of the most important relationships. Now, involving differentiating this, let's differentiate both scenarios. So we have g of f of x is going to equal to x. Let's differentiate this. We'll get 1 since the derivative of x is obviously 1, and the derivative of g of f of x, we're going to be using the chain rule for this. We'll get g prime of f of x times f prime of x. So now that we have this relationship, we can actually divide and solve for f prime of x. So let's divide by g prime of f of x and if we erase this right now, we'll get that our relationship will be 1 over g prime of f of x is going to be equal to f prime of x. Now, this is going to be our first amazing relationship. Now, let's look at the other scenario. If we have f of g of x, and let's differentiate this, we know that x is going to be equal to 1. This is going to be f prime of g of x times g prime of x. And I'm skipping the differentiating part and without writing the symbols and just differentiating right now, obviously. So I'm just, instead of writing the differentiating signs and doing the full work, I'm just skipping and doing the differentiating part right now. So this is the differentiated part of this equation. So now, let's actually divide by f prime of g of x. So we'll get we divide by f prime of g of x. And now, if we erase this, we'll get g prime of x is going to be equal to 1 over f prime of g of x. Now, this is true because we know that since these are inverse functions, these both must be true. So these are two of the main identities which we want to know when doing this, because this establishes a good relationship between the derivatives of inverse functions and functions. So this is going to be the derivative of the inverse function. This is going to be the normal function. But the main one which we're going to be using is this one, the inverse one. The reason is because we already know how to differentiate regular functions, but for inverse functions, this involves a little bit of work. So what we're going to be doing now doesn't involve the inverse identities, which is just this, for the derivatives, but we're going to be actually differentiating the trig functions. Even though they don't involve this formula that I just showed, it's still a great thing to remember. So let's now get to it and start differentiating the inverse, sine, cosine, and tangent. So let's start with the inverse sine. So the inverse sine or arcsine of x is going to be equal to y. Now let's just make a definition of this. We know that the sine of y is going to be equal to x. Now, this may seem awkward because how did I just switch the variables and change this? To make it more clearer, let's just do something to both sides. So if we have the sine, the arc arcsine actually of x is equal to y, let's actually nest this in the sign to cancel these out just to get x, and this will be the sine of y because we have to do it to both sides. Now this is going to be true, and that's how we get this. So now that we have got this, let's differentiate this. Notice that I'm not doing partial differentiation. So that means we must do implicit differentiation. I'm going to make an implicit differentiation video in the future. So this means we're going to get cosine of y. And then remember, since we're differentiating with respect to x, and this is not partial derivatives, then we have to multiply by dy dx. And remember, once we're done differentiating, dy dx is technically going to be our answer, where d of dx is going to be the function, or like to operate. So this is technically the operator, and this is technically the answer. We want to find what dy dx is. Now, we have the derivative of x, well that's just going to be 1. So now to find what dy over dx is, because that's our main goal, we just divide by cosine of y. Now that we have got 1 over cosine of y, people think that this is going to be our answer, but it's not, because we want it in terms of x, because we have x over here, but we have y over there. So what can we do that's going to be amazing? Well, we have to use our trig identities. This is one of the things most people review pre-calculus and learn pre-calculus and trigonometry before calculus, because you can use the trig identities, which you learn in trigonometry, and the things you learn in pre-calculus, to actually help solve these calculus problems. Remember that cosine of y is equal to the square root of 1 minus sine squared of y. Now, if you don't know anything about trig identities, please visit my 3-part series on the trig identities. Now, you also might be wondering how this trig identity arises. Well, we have the trig identity that cosine squared of y in this case, plus sine squared of y, usually it's x, is going to equal to 1. So if we just do some arithmetic, then we'll just get cosine squared of y is going to equal to 1 minus sine squared of y. Now we take the square root, and that's what cosine of y is equal to the square root of 1 minus sine squared of y. And that's going to be where the trig identity comes from. So we just plug it into there. And remember, so if we plug it into there, we'll get 1 over the square root of 1 minus sine squared of y. Now, what was our purpose in changing this into sine squared of y? Because the purpose is we have sine, so we know that the sine of y is going to equal to x. That's what we learned. So that means sine squared of y must equal x squared, right? So that means if we can just plug this into terms of x. Because if this were just cosine of y, we don't know what cosine of y would be in terms of x. But we do know what sine of y is. And since the squared, we're just going to get 1 over the square root of 1 minus x squared. And this is going to be the derivative of the inverse sine. That's going to be the derivative of the inverse sine. Now that we have got that, let's move to our next trig identity, or trig function, which we're going to be differentiating. And this is going to be our inverse trig functions, the inverse cosine. Now, we can use the same method to differentiate the inverse cosine. So now that you have looked at this method, I highly recommend to try it on your own to differentiate the inverse cosine, because it's essentially just going to be the same thing, and you might actually be using the same trig identity at the end. So let's begin. So we have the cosine, and remember the arc cosine of x is going to equal to y. And remember, you can call it the inverse cosine or the arc cosine. Neither is different. They both are the same thing. So now over here, we know that the cosine, the arc cosine actually, of x is going to be equal to y. We know that we can just make this into cosine of y is equal to x. That's what we learned. So if we do that over here, we can get the cosine of y is going to equal to x. Remember that this is going to be number 1 in our remembrance. So say you're doing this on paper and you don't have enough space. Always mark this so that you know that you should keep it. You could erase this eventually or just scratch it out. But remember that this is going to be one of the important things which you need to remember. Then after that, so if we label this 1, 2, our third step will be to differentiate this. Differentiating cosine of y and differentiating x, so both sides of the equation. And remember that since this is in terms of y, we have to do implicit differentiation. We're not going to do partial differentiation because then the symbol would be like this. But it looks like we have regular symbols, and the reason we're doing this is because we want to find dy dx. As I mentioned, d over dx is just going to be the operator, or like the function which we're going to operate this on. So, like say the derivative of cosine of x is going to be minus sine of x, kind of like that. And dy dx is technically going to be the answer once we use the derivative function. So over here, the derivative of cosine of y is going to be minus sine of y. And since this is a different variable, using implicit differentiation, we have to multiply by dy dx. And then this is going to be equal to 1, since the derivative of x is 1. Now, we're going to be doing some arithmetic, so this is step 4. So if we go to step 5, we have to do some arithmetic, and we know that we can divide. So we'll get 1 over, so minus 1 over sine of y. Where did the minus come from? Since it's minus sine of y, I just took the minus over here and put it on the top. Same thing anyways. So now that we've got this over here, we just have to transfer the sine of y. What do we know about the sine of y? Well, we can use the same identity, just in a different way. So we know that cosine squared of y plus sine squared of y is equal to 1. We just do some arithmetic. We know that sine squared of y is equal to 1 minus cosine squared of y. Now, we take the square root, sine of y is equal to 1 minus cosine squared of y, but remember the square root. So that's going to be another trig identity derived from this trig identity. So we can do this and just say 1 over the square root of 1 minus cosine squared of y. Remember, even if we have a square and a square root, they don't cancel since we have to do 1 minus and 1 plus or something like that. But since we have 1 minus in this case, it doesn't work since we have 2 terms. So now over here, since we have that, what we can do next is we know that cosine of y is going to be equal to x. Then the cosine squared of y must equal to x squared. So we'll get 1 over the square root of 1 minus x squared. But isn't this the same as the inverse sine? Well, yes, but the reason it's because is we have to put the minus sign. So that's the one difference that you have to know between the inverse cosine and the inverse sine. Where did the minus come from? Earlier in this step when we had minus sign y, we divided by it. So remember that the difference between the inverse sine and the inverse cosine is the inverse cosine has a minus for the answer. And that's all you need for the cosine, the inverse cosine of x. So now that we have differentiated that, let's look at our last trig function, which we're going to be differentiating today, the inverse tangent. Now the inverse tangent is also going to be easy, but one thing, it involves a different identity. It doesn't involve the same identity, and I'll show you how you get that identity from the identity which we just used previously. So if we were to derive it from that, well, I'll show it to you later, but let's just start. So we have tangent, so the arctangent actually of x is going to be equal to y. We know that the tangent of y is going to equal to x. Now, what can we do? Differentiate this, obviously. So differentiate this. So differentiate the tangent of y and differentiate the tangent of x. Not the tangent of x, sorry, just x. So we differentiate x. So once we differentiate x, we'll get 1 is equal to the differentiation of tangent of y is going to be secant squared of y, and remember dy dx. We can divide, and remember that we can get 1 over secant squared of y is going to equal to dy dx. So what's a trig identity for secant squared of y? We know that tangent squared of y plus 1 is going to equal to secant squared of y. And we know this from your trigonometry class. But how do we get this? Well, if we have cosine squared of y plus sine squared of y, we get 1. Now, if we divide everything by cosine squared of y, we'll get these cancel. So we'll get 1 plus sine squared of y over cosine squared of y is just going to be tangent squared of y, actually, since it's in y, and then we'll just get 1 over cosine squared of y. We know that 1 over cosine is going to be secant, so this must be secant squared of y. And that's how we get this identity from the previous identity. Okay, so we can use this and just replace it over here. So we'll get 1 over tangent squared of y plus 1. Now we know that tangent of y is equal to x, so tangent squared must be x squared. So we'll get 1 over x squared plus 1. Now, you might be wondering, where's the square root? This inverse trig function actually does not involve the square root, because we have secant squared, and since it's going to be squared, we actually don't need to take the square root, because it itself is going to be a trig identity. In this previous trig identity, to get a regular like cosine squared or something like that, we have to that together cosine squared or minus 1 or plus 1, we had to take the square root, because if we said sine squared is equal to 1 minus cosine squared, well, we had sine of y over there, so we must take the square root. But over here, we don't have to take the square root. So now that we are done with the trig functions, we can make this video to an end. If you like this video and if you like this channel, please subscribe to learn more. Thank you.